Museum. Thank you so much for joining us for the Brontë Festival of Women's Writing. Tonight is our headline event, and we're welcoming people online too, so hello everyone online. Thank you so much for being here, and it's actually been a really perfect day because the sky's been clear, there's been some beautiful clouds, and tonight we're talking all about the stars. So I'm very much looking forward to this event, so if you could give a round of applause and welcome on our guest for this evening.
Hi everyone, and welcome to the space edition of the Brontë Festival of Women's Writing, which has also been very wonderful today, so congratulations to Sassy and the Brontë Festival Museum for putting that on. My name is Megan Jones, I work in museums, and I'm just as a visual description, nearly 30-year-old woman with mid-length hair, and I'm wearing very orange trousers today. So before I introduce Libby and Emma properly, would you mind giving a visual description too for our audience?
I'm about to. Okay, you're about to. I'm Emma. I'm wearing a white shirt and I don't know what you call this. What's this? A vest?
It's a tank, I reckon.
A tank.
Yeah.
A woolly tank. It's my first time wearing one of these, so I'm a little bit shy about
It's
it.
very nice.
And black leggings and biker boots and yeah, just brunette. That's me.
Yeah. Lovely.
And I'm Libby. I've got what should be curly hair. It's been all straightened, so I've got frizzy hair.
Yeah.
And I'm wearing a sparkly silver jumper, pair of jeans, and some pink shoes.
Lovely. So to kind of introduce you properly, I'm sure many of you know already, but Dr. Emma Chapman, you are an astrophysicist and you're one of the world's leading researchers in search of the first stars to exist in our universe. It's pretty cool, isn't it, that? Yeah, that's really good. She's also the author of a wonderful book called First Light, Switching on Stars at the Dawn of Time, which we'll be talking a lot about today. And then Libby Jackson here used to work at Mission Control for the International Space Station.
And is a general expert in space travel and all things astronaut.
And you're also an author, so you've written a wonderful book called A Galaxy of Her Own, Amazing Stories of Women in Space. And we're going to hear some of those amazing stories today. You've also written Space Explorers, so yes. Lots of different hats. How are you both doing today? You doing well?
Very well, thank you.
Good,
yeah.
Doing good.
Yeah.
I have just been sat with Emma and Libby back in the, I'm going to call it a green room.
Yeah,
It's a
green room.
And honestly, Sassy walked in to come and get us. I literally was just like,
Basically had this conversation.
Honestly, it was wild. So basically, buckle up. We're about to learn so much about space. And I'm very much like a history, humanities girly. So we're going in. And I was a little bit kind of apprehensive, or a little bit nervous, I guess, when Sassy introduced talks to me, because I was like, I don't know anything about space. But then she told me that you write books for children. And that's okay. So that's very much the level that we're operating at today.
Good place to start.
It is, yeah. So I'm going to ask you first to talk about your books and your writing and your author hats, which are lovely, by the way. Lovely. And then I have lots of annoying questions about space that I just want you to answer and tell us all. And then I'll put it out to you guys for any questions, so please just have them at the ready. And then we're going to go and do a little bit of stargazing, which is just like the most beautiful thing that anyone could ever have. Can't believe it. So Libby, I'm going to start with you. Can you tell me all about your book?
Yeah. So A Galaxy of Her Own is a book that it tells 50 stories of women who were a massive part of the story of human spaceflight, of getting astronauts into space. And I wrote it because people think that astronauts and space travel and human spaceflight is a lot of people think it's for boys, or it's presented as for boys and it's full of boys, and it is a male-dominated industry. But this book, and it's aimed at children, it's 50 stories, it's got 50 beautiful illustrations that were done by students from the London College of Communications. And each one just takes 50 of these women, a little bit about their background, what they did, what their contributions were. And what I would like anyone who reads it, girl, boy, young, old, anyone, to see is that there are so many different roles that are needed in space. It's not just about the astronauts. And I've got some astronauts in there. Helen Sharman's one of them, our first British astronaut. But it's not just the astronauts. It's the people who write the software code, who do the PR, who are the accountants, who are the scientists who are working out where you have to send these spacecraft. Lots of different stories. And if you walk away from it realizing that space is for everybody, not just about the astronauts, and it's not just about the men, then I'll have done my job.
Annoying question, but when you say astronaut, what is an astronaut like? Do you have to have gone to space to call yourself an astronaut?
Yes, sort of, really. So we have astronauts, not all of them have been to space yet. Just recently, the European Space Agency selected 5 new astronauts who will be going to space, and we're calling them astronauts. But so they've got a job as an astronaut. It's basically, to be an astronaut, you have a job as an astronaut just as you're a job as an author or a museum curator or anything like that.
Oh, it's cool, isn't it?
But they go to space, which is very cool.
And would you be able to share maybe your favourite story of an amazing woman in space? Maybe not favourite, or a really good one.
There are so many in that book. It's picking my favourite, but one of the ones I sort of like to share, because I think it tells a little bit about the story of what it was like to write the book as well. So I was going to pick out Margaret Hamilton. And you might have seen a photograph of Margaret Hamilton. It does the rounds on the internet sometimes as a meme. It's a lady standing next to a massive, massive stack of books, which is the code that was the all the computer code for the Apollo guidance computer, the computer that inside the Apollo capsule, the spacecraft that sent the astronauts to the moon in the late 60s and early 70s. And I'd seen this photos. Margaret Hamilton's standing next to it.
I've got it in Lego.
You've got,
I've got it in Lego with some little books next to it.
And it's shared as, oh, look, there's a woman with some books. Yeah. Margaret Hamilton wasn't just any woman. She was the woman who was in charge of the team at MIT who wrote that. She coined the term software engineering. So the coding that was done to get astronauts to the moon was led by a team of women. The team was led by a woman, it was Margaret. And one of my favourite stories about Margaret, she was very interested in maths, she studied, she saw this job at MIT, went, I want to do that, coined the term software engineering. She had a daughter called Lauren, and she was working late nights because it was a massive, massive project. America were desperate to get to the moon to beat the Soviet Union there. So Lauren would come with Margaret in the evenings to work late at night. And one evening, Lauren was tapping away essentially on the computer, big computer that had the code on, and Lauren managed to crash it. And Margaret went, oh, that's not good, because software. You don't want software code crashing on the way to the moon. So she rang up NASA and said, yeah, I found a problem. My daughter's crashed the software code. And NASA said, oh, don't worry, because they're astronauts, right? They're good. They won't do that. Lo and behold, on the way to the moon, the same thing happened, and she had to go into mission control and explain to Jim Lovell, the astronaut, how to undo this crash, this bug that she had found, because they said that astronauts wouldn't ever do the same thing as a young daughter. So it just goes to show children know exactly what they're doing.
Has there ever been a woman astronaut? Has a woman ever been?
There's been plenty of female astronauts. There's been not as many as we would like. There's been about 500 or so people who've been into space. 10-15% of those have been women. But some of that is because we've been sending people into space since the early 60s. And back in the early 60s, the first astronauts to be selected weren't allowed to be women. It was a man's job. We were not going to have women there. Some people really thought women were not suitable or capable of going into space. Absolutely not true. The first woman to fly was Valentina Tereshkova. The Soviet Union flew her, but they flew her very much as a token to win that first woman in space. They didn't then back it up because they thought that women belonged in space. NASA sent astronauts in the late 70s, early 1980s. Sally Ride was the first person to head into space from NASA. Today, when we have an astronaut selection, we see more or less gender balance. But it's taken us a long time to get there because there's a real pipeline of people that have to come, because when we have an astronaut selection, we're looking for really, really amazing people who've done really amazing things. We don't care what they look like or where they've come from, but they've got to have been through that pipeline of having a degree in a scientific or a technical subject, of doing amazing exploring things and being really at the top of their game. And even today in society, we see that girls are just sometimes not allowed or are encouraged not to consider science as something for them. And that's what we have to keep working to change right through, to make sure that when we're trying to select astronauts or anything else, we have equal pools of people, because we've been encouraging everybody from the day they're born that anybody can do anything, and it doesn't matter what you look like, you just go on and get to do the stuff you do. And
we still managed to mess it up.
We did.
The women, the NASA still manages to mess it up, because I was reading about, is it Samantha
Cristoforetti? Yeah.
Cristoforetti. She's got an amazing book. It's her autobiography, and how she got selected and trained to be was it the first Italian women astronaut?
Yeah,
first Italian women astronaut. She went on the ISS, but she wasn't able to. She had a heart set on doing a spacewalk, and the reason she couldn't do a spacewalk was because they didn't make the gloves for the flight suits in a small enough size for her hands, so she couldn't do the spacewalk. And this isn't one of the memes that goes around about, oh well, they packed 500 tampons for one women astronaut. Like, everyone's like, ha ha, very funny, 60s men, ha. This is 5 years ago or something that they were like, you know what, women might have smaller hands. It's like, meh.
We've still absolutely still got work to do. And the spacesuits that were developed back in the 60s, they're the same ones from the moon landing. So it takes time, and it needs people to think, we need to do something about this. So we've still got a lot of work to do.
It's been 5 minutes and we're already like
putting the world to rights.
Yeah. Sorry, just before we go any further, have either of you two literally been to space?
No, and you wouldn't get me up there for anything. Because it's a missile, like you're strapping yourself to a missile and just being like, 50-50, that's good.
We work on being more.
I'm all right.
But once you're there, it's like camping, and really, really smelly camping. You spend 6 months on the International Space Station, very, very smelly. No showers, mostly tinned food or dried food.
Wait. No showers?
No.
So
it stinks.
Genuinely, people don't shower?
Genuinely, there are no showers in space, because you don't feel the effects of gravity. There's still gravity there, but you're in free fall around the Earth, so you don't feel it. So if you had a shower, the water would just stick to you and you would suffocate. So we don't do that. They just use wet wipes, flannels, sponges.
They just wear the same shirts for a week, because it costs so much to lift stuff up into space that they don't take a new pair of pants for every day. They're very much a turn inside out, turn it to the back,
Space is stinky.
Oh yeah, no, I'm all right down here.
That's absolutely wild. Would you want to go to space?
Yeah, it's not been. I wanted to work in mission control, which is what I got to do. But if you said, do you want to, here's a ticket and off you go, absolutely go experience it. I've been lucky enough not to go to space, but I have experienced what it's like to float, to be weightless, because you can on Earth experience it. You've probably all experienced it for a microsecond. If you've ever driven a car over a humpback bridge and you felt your stomach just lift, for a split second, you were weightless. And you can do the same thing in a plane, just an Airbus A320, the sort of plane you get on to fly to somewhere in Europe. If you've got the right pilots and the right clearances, you can fly this plane in parabolas. And at the top of each parabola, the pilots essentially give it a kick at the bottom and then sort of do magic things not magic things, but they sort the engines out so that they balance all the forces, and you are essentially free flying as you go over the top of the parabola inside the plane, and everything inside the plane floats. And so you are weightless and you float just like an astronaut for 20 seconds at a time. And I've done that, and that's a lot of fun. It is, yeah. So I'd love to go, but I'm quite happy doing my job on Earth, because I also have never really wanted to get on top of a rocket, because we try really hard to make them not explode, and we don't, we really, when we put humans on top of rockets, we make sure that we do everything we can to keep them safe. But you are still sitting on top of what is a very carefully controlled bomb. So, yeah.
Has anyone here been to space? Just for, no? Maybe we should all go.
What I will say, Dave, if you want to go, you start saving.
Yeah.
And kids, I say this to kids, any kid who wants to go to space, we are now living in an era where if you're really rich and you've done really, really well and you've got a spare 50 million quid in your pocket, you can buy a ticket and go to the International Space Station for 2 weeks. But if you've got just a spare 200, 300,000 pounds, you can buy a ticket to go on a flight that takes you into space and you float for 6 minutes. Virgin Galactic have just launched their services now. And we'll see where we get to in 50, 100 years' time. But, 50, 100 years ago, 50 years ago, only the rich people went on aeroplanes. And we weren't all zooming around the planet on our £50 tickets. I don't know which way space tourism will go. There's a whole lot of other considerations about the planet and all sorts of things. But I do think it's true for kids today that just as I dreamed of one day maybe buying a ticket on Concorde and experiencing supersonic travel when I was a kid, I think if you wanted to, you could choose to go and earn the money, to save the money and potentially go to space. So, it's not an impossible dream now.
Do you think that's only a good thing, or if people going up, is that like ruining space?
It's not ruining space. There are absolutely considerations about the planet and carbon footprint, but everything we do in space is all about pushing the bounds of technology. I was talking about Margaret Hamilton and writing this software code. You'll know all about this. Everyone will know all about this from the instruments that she builds. When we put things into space, we have to think in different technological ways. The computer that Margaret Hamilton wrote the code for took a computer that was the size of a room and shrunk it to one that's the size of a shoebox. And now we've all got computers in our pockets, which are way more powerful. What we're doing with space tourism is pushing technology in interesting ways. And those flights that are taking people into space for 6 minutes could well lead to plane travel that might get us from London to Australia in an hour. And if you do that, and if it's sustainable because it's using the right fuels, which people are looking at, that don't pump a load of carbon into the atmosphere and so on, it may lead to new technologies, will in some way lead to new technologies that benefit all of us. And that's really what a lot of space is all about, and research.
And if it's reusable as well, because there's a huge amount of money going into because it works out financially for the tech bros like Elon Musk, etc., to when they launch a rocket to have most of it come back down, that they can then use it again for the next one. Whereas the Apollo missions, it was, if you've ever seen a Saturn V rocket, they're they're not that big, but let's say they were that big, but the bit that's actually left when it comes back is, and they all just get chucked at various stages, and so you get space junk, what is called space junk, and space junk is all around Earth. And I've got a T-shirt of all of the positions of the space junk in like silver, and it just looks, if you Google an image of Earth but with the space junk highlighted, it's really upsetting. It's like seeing the Lake District, but just absolutely covered in trash. And there are real considerations here because the tiniest piece of space junk can be fatal to the International Space Station, for example. So a millimetre-sized meteorite can go through the breathing tubes of the oxygen tubes that keep the thing ventilated. And
avoid that?
well, they don't always. They have to move. Which you know way more about than me, but they have to move the International Space Station. But that means that we have to, like people like me, have to develop radar techniques in order to know exactly where it all is. And if we keep putting space junk up there is going to be a moment where you start getting a cascading effect. And the big stuff starts to crash together, and then it makes more little stuff, and you get crashing and crashing and crashing. And then you are really in what could be a very, very fatal situation for any astronaut that's up there at the time or trying to get through it. But there is more and more. People have woken up to that very quickly, actually, recently anyway.
But it's not just the astronauts. We care about the astronauts, but all of us, every single one in the room has probably used space today. The satellites that are up there. from if you put something in your phone to work out the directions to come here, you're using the global positioning satellites. If you have paid for anything, you've been using Space Today. If you're looking at the weather forecast, you're using Space Today. And all of those satellites, if we end up in a space junk effect, it can wipe out all the satellites we rely on, and we'd really notice it. And it would wipe out the spacecraft that are up there doing the science that Emma and others use to understand the universe that we live in, understand things that in the end help us all develop technologies and understanding to make our lives better and look back in time and solve mysteries.
Twitter.
Yes.
Knock out Twitter.
Emma, could you tell us a little bit about your book?
Yeah, so my book is a lot less useful. It's a very, very research-based book called First Light, Switching on Stars at the Dawn of Time. And it is about the first billion years in our universe. So that encapsulates when the very first stars roared to life, when the very first galaxies formed, when you have baby black holes. And it's... I know! It's so sweet. Little baby black holes. And over this billion years, these things grow up into the kind of things that we see around us today. But it's a very, very exotic time because we have very few observations of what was going on back then. And so it's kind of a lost era. It's the lost billion years, the lost era of the first stars, which is why I got into it, because it just sounded like Indiana Jonesy, and I was like, oh, that's cool. So the book is about that. The book runs through everything from what is a star, how do you form a star, what happened at the very beginning of the universe, at the Big Bang. So if you believe that there is a first star, it means that you believe that there was a beginning. So we have to talk about that. So we talk about the Big Bang. And then we move on to kind of how can we detect this time? How can we actually observe it? How can we learn about it? And that goes into kind of the second part of my research, which is I'm a radio astronomer. So I use radio telescopes in order to receive radio communications, for want of a better word, from the first billion years that have been travelling to us all that time, and then trying to kind of just decode what that means, how many stars were there, how big were they, because these were massive. So the sun, we say that's the solar mass. The first stars were on average around 100 times the size of the sun, and that's just the normal. And they died really quickly, only in about 1 million years, as opposed to about 9 billion. 9 billion that the sun's going to live. So it's a very different time. So it's not just about filling in kind of for the sake of it, like, oh yeah, this is what happened at the beginning. This is about a completely different time that you cannot recreate now. So it's about finding the first ancestry of the human species. It's it's the equivalent of doing that on Earth. It's about looking at how it was all formed. It's completing the family tree. So it's an exercise in history.
Okay. So in a nutshell, I have been reading your book, and you have this diagram that's really stuck out in my mind, because I need someone to draw stuff out so that I can understand what on earth is going on. And it's not even on Earth, there you go. But it's, am I right in thinking? Big Bang, stuff. Big gap where we don't know what's going on.
Yeah.
And then stuff.
Yeah.
So your job is finding the stuff. The stuff that you
Love this. Yeah.
Why is there that gap?
Why? So we know what happened at the very beginning, the Big Bang, mostly by, completely actually, just by looking around us now. So it's not that we've seen the Big Bang, it's that we have understood that it can only have been a Big Bang, because one of the main pieces of evidence is that if you look at every other galaxy that's around us, they're all flying away from us, with very few exceptions. They're all flying away from us, just like you'd see in an explosion. Now, just to caveat what would probably be a question, it doesn't mean we are the centre of the universe, because if you are in any explosion, whether it's on Earth or in space, you can position yourself on any of the pieces of debris, and you can imagine everything is always moving away from each other. It doesn't actually mean that. But anyway, all of these galaxies are flying away from us. Like, what's that about? And then you start to work out, okay, what if it was this hot, like if it started like this, how many kind of chemical elements would you have in the universe? Like how much of the universe would be hydrogen? How much of it would be helium? And you can calculate that mathematically. And then they found ways to measure this, and it matches exactly. So the Big Bang is kind of like okay, that's what we know what's going on. And then you have one snapshot, which is called the cosmic microwave background, which this is about 300,000 years after the Big Bang. This is like this is the farthest back we've ever seen and will ever see. And it's because it's the moment when the light in the universe was able to travel freely. So the Big Bang's really violent. And it's like, if you imagine having a penny at the bottom of a jacuzzi, you've got your jacuzzi on, bubbles everywhere, it's just so violent. The light just can't get through. So you're looking at it, and you're like, you know, where is the damn thing that I've dropped? You turn the jacuzzi off, which happens about 300,000 years after the Big Bang, when the universe has got big enough that everything's cooling down a little bit, everything's calmer. Suddenly the light can travel really, really clearly. And that's the kind of point where we can see back to us. That's the furthest back. So you've got these two little points very early on, and you've got nothing basically for what I would have said 1 billion years until the James Webb Space Telescope launched a year and a half ago, and now that's been filled out a little bit. And then it's a case of having the most powerful telescopes possible. And to get back to the farthest time, you have to have radio telescopes. You really have to have these telescopes that pick up the lowest energy light. So there's lots of different types of light. There's optical, which we're all used to. There's stuff like X-ray light, which you'll have used if you've broken anything. There's infrared light. It's all light, but it's all different energies. And when something's been traveling to you from the Big Bang across space-time for 13 billion years, you can imagine it's got a bit tired. Like it's you know, you would. So even what was the brightest, most energetic light back then has kind of just like shifted into the winter of its life, into radio. And so you have to have a different kind of telescope to really press back. And it's only now, as of last July, that we've had the technology to begin building what we call Square Kilometre Array, which is a telescope in Western Australia that we're building to hopefully pick up the signs of the very first stars.
Wow.
It's a lot of words, wasn't it?
It was a lot. What I think is, this actually brings me really nicely onto my next point, which is for both of you, because that's, I think, the similarity between sort of the writing that you do, the books that you have. They are for a non-specialist audience, so yours are for children. And like, I can understand what you're saying when I'm
reading my mum.
There you go.
Because I wanted my mum to know what I did.
Yeah.
So I gave it to my mum.
But I really appreciated reading your book, Emma, the like analogies that you use. So that one that you explained about how everything is, the universe is expanding, everything's moving far away, and I think you described it as putting a pen or putting a mark on a balloon and then blowing that balloon up. And that to me was like, oh, okay, I can picture that, I can see that, and I can understand that now. So I wanted to just ask how, with your author hats on, that's been kind of taking those really like quite unreachable scientific ideas and reinterpreting them so that people like me can understand them.
How do I do that? I always think of talking to my nieces and nephews, and I think it's also just remembering that there's no such thing as a silly question, right? So when someone says that, I just find a way to go, well, imagine this. Imagine, in fact, we were talking about the parabolic flights, and that when I explain that, the way I have to do it to help me understand it and that I can share it with everybody is go, well, imagine you've got a big, clear beach ball and you stick inside it like a bright yellow ping pong ball. And if you give it a kick, you see the bright yellow ping pong ball inside this beach ball floating. And that's what's happening inside the plane. And I have to break that down in my own head to go, how do I understand this? It's a little bit like when I was trying to learn German, because I lived in Germany for a long time. The German teachers were, they were just saying it's it's daddy does this, that, and the other. You have to learn all these different words because they have about 12 different words for the, and each one means a different thing. And the only way I could learn German was by translating it into English and understanding the equivalent in English to then understand the German. And for me, it's just that thought process. And that's what I have to do for myself. And if someone says, I don't understand this, well, why would you? And I can just break it down in that same way that I've been thinking about it and share with people. And if I can get my little people to understand it, and I reckon kids are the most intelligent, bright people, and they absorb so much. If you can get kids to understand it, it helps everybody understand it. So
has a kid ever given you a really good idea?
Oh, yeah, all the time. They're the best ones because they're not constrained by the world. We get so used to things being the way they are, and the kids will come at it. I can't think of an example right now, but they do. They come with this massive sideways question, and you go, "Oh, that's really interesting." Like
my daughter asked whether the moon would go off in a power cut the other day, and I thought that just blew my mind. It was like, that's wow. But I'm the same in that it's for me. I do a lot of talks and I give a lot of talks, and I always find that the best questions come from under 10s and over 50s, because these are the people that just don't give a crap. They don't care if anybody feels that they look stupid, or they're just there. They want to know what they want to know, and then they want to get on with whatever it is. So you get best questions, and you don't get, this might be a silly question. You don't get that almost hunching up of like, oh my God, I can't believe I've had to ask this. And my superpower is that I've never lost that, in that I don't care whether I look stupid. I always just want to know the answer. And so writing a book, for me, I learnt so much writing it, which you're probably not meant to say as an author, because you're meant to kind of come across as like a super expert. But actually, I wasn't. Like, I knew the broad brushes of it. I've got a PhD. I do my job, sure. But in terms of like the fine structure details of each chapter, like, but why were the first stars so massive? And when you're doing a PhD, you don't have time to actually dig in to anything that's not your real question, like your question. So you don't have time to dig into it. So this book was the most pleasurable thing for me, because I got to dig into every stupid question that I had been kind of keeping in for 4 years. And I was like, right, why are they so massive? And my partner calls me the queen of analogies, and it's just because it's how I think. That's the only way I can think about it. I'm just not one of these people that can think with big words. I'm just like, I think with little words and ideas and pictures and bunnies now and then just hopping across my head. And so
I think it's a real skill to be able to do. I think it's so refreshing to read something and be like, oh, okay, it's so lovely to read something that I really do understand and I get. So thank you for doing that. You wrote in your book as well, and this is an interesting question I wanted to ask both of you, about how when you have your more kind of academic hats on, I think you said, Emma, that in science papers you're never going to find an exclamation mark, even though the ideas are so exciting. And my question is, I guess, like, when's science going to stop playing it cool? When's science going to start to like embrace that? Because the two tones are so different. When do you think they'll ever merge?
It's such a bugbear for me. Well, again, this is something I just don't care about, and I've got in trouble with at work, because I will write about something because I'm excited about it, and so I write as I speak, quite colloquially, not using big words because I don't know many big words, so I just write, and I won't use many exclamation marks, but if something's exciting, I will underline that. And that's not cool in academia. What's cool in academia is to say, didn't you know this already? Well, fine, if you want me to explain it to you. And then, like, righty, typey. And you spend a week trying to get through these 28 pages of what? and what is the point of scientific paper if not to communicate? Yeah. It's science communication. And so I teach my PhD students, I make them do outreach with kids or teenagers. I make them do outreach because if they can communicate with those people, they can communicate their ideas to PhD Viva, for example. Yeah. But no, you're right. It's academia's got a right stick up. It's
For sure. How do you deal with such big ideas that are literally out of this world, and then you're typing that on a computer, you're mission control, you do all that stuff. How do you put your laptop down and then go and put some fish fingers in the oven?
It's for me. I find this so exciting and refreshing to come and be reminded how cool it is.
Yes.
Because it's work, right? And it's I've been doing it for 20 years now or something, and so I'm going to name drop things now. But I had lunch with Tim Peake on Thursday. But he's
he as nice as he seems?
He's as fabulous as he is.
Oh.
But
What does Tim Peake have for lunch?
we both had quiche.
You know what? He seems like a quiche man.
But
You just think quiche.
You do.
Someone else was having steak, and he was like, "Oh, I had a big steak last night." So anyway, he likes steak too. But that's my point. For him, colleague, someone I work with, and another person had come along. I was like, "Oh my God, it's Tim Peake!" And it's so nice to be reminded how fabulous and exciting the work we do is, because it's very easy to just take it for granted and to be everyday stuff. But it is that remembering of it, of the excitement, that then helps me go, no, this is so cool. I want to share it with people and to explain to people why this is important, what the benefit's doing for everybody. Because space is not cheap and it costs money. Probably doesn't cost as much money as you think it might. But it's so cool and so exciting that I like being reminded by it, by people coming and going, oh my God, it's great, because I go, yeah, it really is. It's lots of fun.
Yeah.
It's the other reason I tell my students to do outreach, is because it really gets rid of your imposter syndrome. And that's why I did it as a PhD student, because I just felt stupid all the time, because I just didn't get anything, because it's really hard sometimes, when you're trying to learn what is 100 years worth of radio astronomy, you're kind of, for some reason, telling yourself off for not knowing it within the first 6 months. Yeah. But actually, when you go out there and you communicate it to a kid who almost faints when you talk to them about black holes, then I made someone cry the other day by talking about an inflatable planetarium I had and what it could do, and they were like, "I'm sorry, it sounds so wonderful."
They're fabulous. Eh? You go in, and it's like you're going in a tunnel, and then you've got the whole universe inside.
Wait,
I've got my own one. Yep. So I've got a blow-up planetarium. I do the outreach for University of Nottingham, and so we just won a grant. I'm going to name drop them. Royal Society just gave us some money, and so what we've done is we've got this big blow-up planetarium that's about 4 meters by 4 meters, and you go in and you can project whatever you want on it. And so we're taking it. Normally people take these things into primary schools, but what my project is about is going into special needs schools for children with complex learning and physical needs, and into retirement villages, because I'm a believer in lifelong learning in any shape and form. And so I really wanted to find the two communities that didn't get to access space anymore, and that's because this makes me cry a little bit actually, but it's because my dad came round about a year ago, and I was like, look, the moons of Jupiter, just look through my telescope, you can see them, and he couldn't see them, and there had been a moment in time where his vision had just got bad enough that he could no longer see, and it hurt me a little bit. And so the idea of being able to bring the sky towards people and remind them, because the sky is for everyone, and the sky connects us, and everyone's got a memory to do with the sky, even if they're not astronomers, or they don't even care about the stars. They'll remember that moment in Hawaii on their honeymoon when they were walking under the stars, or so, there was something like that. And then for the kids, these children are to the point where we're talking, actually, funnily enough, about just basic senses. So they're 6 months old in terms of their mental age. And so because space smells so horrible, but apparently it also smells a little bit like McCoy's steak crisps, we found out.
Because it's so peaking.
Yeah, we've been literally just getting them to spell McCoy's steak crisps and putting them on the trampoline to try and very slowly simulate that feeling. Yeah. And I've completely lost track of why I started talking about this, but yeah, I love my planetarium.
Why? This is interesting, because we've gone from, I thought that we were all just going to have a collective cuddle and cry then, because that was so sweet, but then now I'm like, Does space smell like McCoy's crisps?
Well, apparently this is what people report, that when the astronauts come back down and step out of the capsule, there is a smell of burning meat and smoke and like a barbecue-y smell. And so a McCoy steak crisp was the
It's not because we've got crisps in space. It's because you've got a vacuum. There's no air up in space, but there are still chemicals and so on. And then actually, when you expose the material of space, the dust and so on, to air, it oxidizes, and you get this smell, and you get this sort of slightly metallic-y burnt steak smell or whatever it is. So there is a smell of space that they do talk about, and it's all because of what's in space, the remnants of stars, essentially.
Yeah.
When astronauts first get back from space, what's like the first thing they want to do?
Usually go outside and sort of smell the rain and the weather and so on, because they've spent 6 months in a tin can that's got recycled air, which is quite stale, where you are drinking your own recycled urine, which is what we do as well, but it goes through to some processing system as well, so it doesn't quite happen in our house.
I'm sorry, what?
But so they've been basically stuck inside an air-conditioned tin can for 6 months. And they haven't felt the rain, they haven't felt the wind, they've seen sunrises and sunsets every day. You go around the Earth 18 times in 24 hours. You see lots of sunrises and sunsets, but not like the same as just sort of being in a dewy forest and sort of watching the sun go down and the stars come out. So that's what they want to do. They also are so used to floating that for the first week or so, they'll just put their coffee cup out, expecting it to float, and it'll drop on the so they really have to adjust back to feeling gravity.
Put the China away, they're coming back home.
The 6 months that that an astronaut spends in space, their bones and their muscles get weak, in the same way that happens to us all as we get older. And so actually a lot of the research we do on astronauts is about understanding why their bodies change in space, because they get weaker in space for 6 months. They come back to Earth, they get stronger again, their bones and their muscles regenerate, but it doesn't happen to us as we get older. And so there's some great research in the UK looking at what that's happening and so on. So they have to get fit again, just smell stuff. They have to learn how to not drop things on the floor again. They have to learn to walk again, their balance has to regain. But what they all want to do is just go and feel Earth. It's a very special place.
How long, in fact, Sassy, how are we doing for time?
About 10 minutes.
10 minutes. God. Right, okay, I'm going to ask you some really quick fire questions, and then I'm going to ask you guys some questions as well. So very quickly, how many astronauts are there in the world? I literally would have no idea.
A lot. There's been about 580 people go to space.
Wait, at any one time?
But at any one time, there are normally 7 people in space at a time on the International Space Station.
Okay. What's the furthest we've ever been? Me and my partner had an argument about this earlier, because I was like, yeah, I wonder, like, we've been to all the planets, that's really cool. And he was like, no, we haven't been further than the moon. Humans have only gone as far as the moon. Right.
The furthest they've orbited is just to the far side of the moon. We're going to send humans back to the moon in a couple of years' time, and they're going to go, so it's about 250,000 miles to the moon. And the astronauts that are going to fly on Artemis 2 in a couple of years' time, they will go the furthest we've ever been. The short answer, humans have been as far as the moon, but spacecraft have left the, not the solar system, but the magnetic influence of the sun. So
that's Voyager 1.
Voyager 1, Voyager 2.
And Voyager 2 now.
And
Voyager 1 and Voyager 2 have broken into interstellar space as much as you can round it all up, yeah.
I had loads of questions around time and space, but I honestly think there's just not enough time, hilariously. But Emma, I feel like a really good way of summing up is if you can maybe explain to everyone what you told me was the reason you got into what you do and what you did before
Yeah, okay, sure. So I did all of my work experience. Well, I was a really precocious child, and I wanted to be an Egyptologist. And I've got all these images of me like painted as an Egyptologist. And I tried to learn hieroglyphics. And I did my work experience was when I was 15, and I was packaging 5,000-year-old shoes for the Ashmolean Museum in Oxford. I'm absolutely sure this is what I wanted to do. And then my head got turned by a book on physics and how you could look back in time and even potentially travel in time, but look back in time, do all these things. Oh, my mind was absolutely blown. And so I went to university to study this. And again, then I took a cosmology course. And they said, yeah, you can actually just look back in time using telescopes. And I was so floored by this idea that you could access this past time using technology that we've built, that I ended up wanting to do that as kind of like the historian in me, basically wanted to be a historian who used a telescope. So I wanted to not look back 5,000 years, but I wanted to look back 13 billion years and fill in this lost time that has left traces around us now. And it's actually really easy to do. It's really easy to look back in time, because you might have heard on QI, the light from the sun that gets to us is 8 minutes old. So we're seeing the sun as it was 8 minutes ago. Now you can take that a little bit further and say the light from our closest galaxy, Andromeda, that takes 2.5 million years to get to us. Equivalently, if we waved to Andromeda, it would take 2.5 million years for that light to get there. So they would see us they would only see me waving in 2.5 million years. So equivalently, you could think of it as like anyone that's on Andromeda now is looking at the earliest ancestors of human race, just beginning to walk on Earth. That's what they're looking at when they see Earth. So all I do as a job is I use radio telescopes to tune into light that has been traveling for so long, 13.5 billion years or so, that I'm actually watching the first stars grow up. So this is way better to me than packaging shoes and trying to kind of guess, I wonder who wore them, what they last ate. I actually just get to, it's hard, but build a telescope, turn it on and watch. And it is the equivalent of if the speed of light was lower, it would be the equivalent of me being able to set up some very fancy satellites and mirrors and watch the pyramids being built. Like there's nothing illegal around it cosmologically. Like it follows all the laws. It's just watching it firsthand, and how can anyone not want to to do that?
Literally just so beautiful.
Really can't wait to know. Does anybody else have any questions? I'm going to put it out to you guys now. Yeah.
So when I think of like nature and our natural world, I think of this planet and like trees and ocean and stuff. Do you think we should, or do you think with the developments in space travel, do you think this will happen, that our definition of our natural habitat will expand to include our galaxy instead of just our planet?
Yeah, so this is something I've thought out quite a lot in terms of what's your definition of home. So how your hometown until you're 10 or whatever, but 17, and then you go to university, and then that's your home. And if you go to another country, your home is England, and and it goes more and more like that, and we become more tribal almost in these different shapes. And I think that as we start to extend outwards, the solar system, I think, is mostly home for people because we're very used to the number of planets. Then you start thinking about like the arm that we're on of the Milky Way. I think that's going to start becoming more home as we explore that more and we start to understand the farthest places. And so for me, it's really narrow-minded of people to think that astronomy, even pure research side, is kind of the useless science that just gets people into medicine. Because what astronomy is you can add exo or astro to any job on Earth and make it about space. So at the University of Nottingham, we've got an astropharmacy department who look at the effects of taking paracetamol on Mars, because you might get a headache on Mars. You know, you've got the fact that we do need to mine meteors and meteorites. So I really do think that we will see I think we're already there, actually, to be fair. I think we're already at the point where the solar system's our habitat. We just have to be careful to keep up with the legislation, such that I heard on Radio 4 this week that they've just passed a law regulating part of the high seas to make sure that people protect it. And I'm like, people have been going on the high seas for how many hundreds of years? And we've just brought the law in that says maybe we should protect it. So what, we're expecting that in 500 years? Yeah,
we're working on it.
Working on it.
I think, do we have time for one more question?
Yeah. There's a question from Ruth from online. So who's tuning in? Hi, Ruth.
Hi, Ruth online.
Yeah. Ruth's got a question for Libby, and Ruth wanted to know, did you know all the 50 women that you chose for your book before you started writing? Did you come across any exciting or surprising stories when you wrote, and what was that process like?
So, no, I didn't know all of them. I knew I had to write 50 stories, and there were some really obvious ones to me. Helen Sharman, first British astronaut, Valentina Tereshkova, first woman in space. And some I drew on from people I'd known more recently, but some it was one of the joys of writing it, was going and uncovering these stories that I didn't know and then sharing them with everybody. One of the things I took away from it was how important it is that we share stories of history and so on. What I wanted to write a little bit about was, I knew there were the women who had built the computers. I spoke actually about Margaret Hamilton, who wrote the code for these computers. The computers had to get built. And they were built, computer code is all made of ones and zeros, and that's the language they're written in. And this 1 and 0 code was literally sewn into rings and copper wires. And they got women who had really dexterous fingers who've been making watches to do this, because it was such fine work, and they were so important to the moon race that they were paid to sit around and do nothing, because the engineers were worried if they'd let them go, they'd go back and making watches and they wouldn't be able to come back. Trying to find the names of these women who had built this was nigh on impossible. And in the book I have an illustration and a quote from all the women in there. And I'd wanted to put a voice to these women who had made the computers. And I went and I looked at the company who had employed them, Raytheon, and on their website there's a sort of note that says, sorry, we don't really do this, we're not interested in this. And I traced things down. Eventually I found a BBC internet article from about 10 or 15 years ago where they'd tracked somebody down, and I got one name. And I've got a quote from them. And that's it. And it's to me, that the importance of recording everybody's stories, everybody's contributions, of not taking for granted the little things that happen in anything, no matter who is doing, is so important, because you never know people's contributions and where they go to later. So no, I had a lot of fun uncovering lots of different stories in that book.
Ruth from online, that was a great question.
Thank
Shout
you.
out to
Thank
Ruth.
you, Ruth.
Yeah. Do we have time for one more, or do we need to wrap up? One more. Sassy's going like this. So I think if anyone else has got a question in the audience.
Yeah, you were saying earlier, if you believe in the Big Bang being the beginning of the universe. So I've heard a lot of conversation about that. Do you have any thoughts?
So as a scientist, you're never meant to make definite pronouncements. You're meant to say everything within a certain probability, everything like this. The evidence for the Big Bang is such that there is no other explanation that anyone can, and people have tried, that fits all of the data, because there's several different independent sets of data. You've got the flying galaxies, you've got the you can actually measure the temperature of the universe, and it matches exactly what it would have cooled down to by now. You can see this background radiation, even when you used to turn your TV on in the before digital radio, digital TV. You had the snowflakey. About 1% of that was the noise of the Big Bang. So there's just so much evidence that I have an open mind, and
so not so much that the Big Bang happened, but was that the beginning of everything? I guess is more the question.
That is where faith comes in. So there's science and there's faith, and I know scientists who have faith. I'm an atheist, but there are people, for example, Roger Penrose posits this idea that you can have an expanding universe that then collapses and then expands and then collapses and expands and collapses, such that everything that has happened before has happened again, will happen again. And then you get into philosophy, and what would that mean? Would your second life be? You get into all of these philosophies. The thing for me that stops me from, as you can tell, I'm a very curious person, but the thing that stops me from being curious about this is that it's not testable. And when something's not testable, I tend to lose a little bit of interest, because then it goes into the area of faith for me, which is fine for other people to want to know what sparked the Big Bang, why did it spark. But for me, because we can't know, there's just so many other things to know that I tend to wander off and get distracted.
I tell you what, for me, helps me sort of think of things in a different way, or at least try to understand where humans are in all of this, is I always imagine what an ant thinks of the Earth. Because we don't know what's at the edge of the universe, we don't know where it ends, we don't know if it wraps around again. If you're an ant on the surface of the Earth, I don't think an ant can probably imagine that there's aeroplanes in the sky. Their world is very two-dimensional. And if you're an ant, you're never going to understand that the Earth goes all the way around in all different directions, because you're never going to be able to travel that far. And I just like to think of sort of thinking, well, if that's what ants think of the world, or can't understand about the world because of their size, and then you've been talking, Emma, about the scales of the time that we're in, and we've got amazing technology, and we're peering in all these different directions and learning things. But I rationalise it in my head of going, well, yeah, we're the ants of the universe, and sort of, so what else is out there? Well, it's out there, but it's, to me, at least for me, beyond my comprehension, because I don't know what happens at the edge of it in the same way that an ant can't go all the way around the world or up into space. So
we are all the ants of the universe.
And that's where we're going to leave you today. Thank you so much to Emma and to Libby for coming and talking to us and blowing our minds. Your books are down in the foyer, I think. Yep. So get one, get your mind blown even more. And should we have a round of applause?
Thank you all for coming. If you would like to join us, we're going to put this in practice and do a little bit of stargazing on the Parsonage Field, which is just behind the Brontë Parsonage Museum. So if you would like to join us, we'll just congregate outside the West End Baptist Church here. It's about a 2-minute walk just past the museum up to the field, and then we'll be joined by the Bradford Astronomical Society, and they've got some telescopes out as well. Hopefully we'll be able to see something. If we can't, they've got a little spiel about the Brontes and stars, and it's going to be really exciting anyway. So if you'd like to join us, meet us outside in 5 minutes' time. But if not, have a lovely rest of your evening. Thank you so much. And thank you, Mary.